Hey everyone, it's Tamás here and welcome to another episode of React Native. Today is a follow-up on our previous video about Flappy Bird, and we're gonna aim to turn this monstrosity, what we built last time, to be something more production ready, something like this. Well, exactly like this. In order to do this, I created a to-do list. I love to-dos. I'm still using Wunderlist even though Microsoft bought it, but I came up with a set of action items we need to do in order to make it production ready and make it like a game that people would enjoy playing beyond 10 seconds of gameplay. So first of all, we're gonna add some real graphics. We're gonna change the gameplay a little bit. So right now, if you check the game, the bird starts falling immediately. I want to make it idle until the first stop. I want the floor to move. Right now it's pretty static. A moving floor will add a little bit sense of motion to the gameplay. We're gonna fix the flappiness of the bird. Right now it's a bit weird, like sometimes it jumps way too high. We're gonna rotate the bird based on the direction it's facing, and as you remember, like right now the pipes are pretty static, so they keep repeating themselves. So we need to randomize the pipes, and last but not least, we need to count the score. All right, so let's get to it. Let's add some real graphics. Now, normally I would ask my designer or hire someone on Upwork to create graphics for this kind of things. And because it's for demo purposes, I just went on Graphics River and bought this Flappy Duck package, which costs $7. I do recommend it. It's a pretty simple but useful package. But if you want to build something for the App Store, I recommend using your own design. So if you are not a designer, hire someone. I'm pretty sure any designer can do this in like a day or so. So I already sliced up the package and added the images we need in under /assets images. I added the background, 3 states of the bird, a tile for the floor, a repeatable pattern for the core of the pipe, and a image for the pipe top. I also downloaded a font which is called 04B_19, very cleverly named, and added it under images/fonts and linked it up with React Native. If you are interested how to link up, I created a Medium post. It's linked below the article, and I'm linking to another Medium post on how to add fonts. It's super simple. You just change the package.json file and link it up, and that's about it. All right, let's get to it. So at our current state, the code is pretty messy. So let's do a bit of a cleanup. So as you remember, we use this wall component for rendering both the floor and the pipes. We need to change that, so we're gonna import floor from floor, and let me copy wall, new file, floor.js, call it floor, and yeah. So we used to pass in the width and height as a size prop, but it also receives a body which is a Matter.js body, and you can actually calculate the size pretty easily. So let's do that so we can save a bunch of code and it's going to be much nicer this way. So this props.body. Now Matter.js object has a bounds with a min and max object with x and y coordinates. So you can calculate the width by max.x minus this.props.body bounds.min.x. Yeah. And same for height. Cool. So we have width and height. We have the container, and we don't need background color anymore, but we need an overflow hidden, which will be useful in a second, and the flex direction row. And we have this image asset here, which is called floor. It's a square image. Obviously our floor is not square, so we have to repeat this pattern. In order to calculate how many times we need to repeat, we gonna do a const image iterations, which will be math.cl, and it will be width divided by height. So because it's a square, you want to know how many times, because it's a square, width and height is the same for each iteration. So in order to calculate it, calculate how many times we need to iterate, you just divide the width with height. Now this will likely bring in one more iterations than what we need, so that's why we had the overflow hidden to hide that last one. So I'm gonna wrap this inside here, and I'm gonna import image, and we're gonna do array.apply null array image iterations dot map, which will give us an element and an index, and we're gonna return an image, style equals width, which will be actually the height, and the height, which will actually be height. The key will be index, and resize mode equals stretch, and source equals. I created in the assets folder the usual images.js, which have a floor attrib. So I'm gonna do import images from /assets images, and the source will be just images.floor, and close this off. Okay, cool. So this is how we're gonna render the floor. Now in our app.js we already imported it. Let's do a little bit of cleanup. So I want to get rid of my pipes because we're gonna render the pipes in a different way. We're not gonna need ceiling. I realized the original game doesn't have a ceiling, so we're not gonna do ceiling. But we're gonna do two floors because I want to move the floor at some point, and in order to do that we need two of those. Okay, so what we're gonna do is constant. So this is the center position, which or floor will be 50 points high. So this is still valid. This is still valid. Valid. Yep. And in our body we don't need the size anymore because we are extrapolating it from the Matter.js body, and we don't need the color. What we need is a new renderer, which is floor. Okay, cool. This will be floor 1 actually, and let's add that. Let's add another one screen later. So floor 2, and this will be constant max width plus this. Now one trick when I originally did this, I realized that because we're gonna move this floor, you need to add a little bit of wiggle room for the engine, so we're gonna actually make it 4 units wider than it should be, because otherwise it would flicker. When you are moving, you would see the background, and that's not something what we want. So we're gonna add floor 1 and floor 2 to our word and remove all these things, and we're just gonna define a floor 2 here. Okay, so that should take care of that. I want to change the gravity to be 0 at start. Remember, one of our to-do list is idle flight until the first stop. So I'm gonna change the gravity of the bird to 0, so our bird's not gonna fall immediately. And I'm gonna get rid of some stuff from physics. I'm gonna get rid of this entire type logic here, and let's try to build this. We have a floor, and as you see, we're still applying force to our bird, so it just flies off because there is no gravity. Amazing. Okay, so let's do a little bit more. Let's add the background. So I'm gonna do a background image which will have a position absolute, a top 0, bottom 0, left 0, right 0, with constants dot max width, height constants dot max height. Okay, and before the game engine, so we want our background to be behind the game. Let me import first an image. Also, let me import images from assets images, and let's add a background. So image source equals images dot background, style equal styles dot background image, and resize mode will be stretch. All right. Cool. Background. Now let's take care of our bird. First of all, let's add the same logic what we added for the floor, for figuring out the width and height. Here. Cool. And what we want to do is, so our bird gonna have essentially three poses, 3 phases actually. We're gonna animate this. So how do we do this? I'm gonna pass in a prop. I'm gonna call it pose, and we're gonna pick an image based on that. So let image equals, first of all, import image and import images from /assets images, and image will be images and bird plus this props pose. Yeah, I guess that's it. We don't need this image. Position absolute, top left, width, height. We don't need background color at all. We need a resize mode equals stretch, and we need a source which will be image. Now our bird currently is set at where is it? Set at 50 by 50, and set at 25% on the x-axis. First of all, I want to move it to the middle because the original game has it in the middle, and Second of all, I want to define a couple of constants for the bird size, because this won't be a perfect square. So bird width, I still want the width to be 50, but the bird height is a bit different story. So our original image size is 120 by 99, right? 120 wide, 99 height. So what we can do is, so we want to scale it down to 50. So I'm going to divide it by 129. This will be the ratio, and multiply it by 99, which gives us 4125. So let's just agree on 41. Right? And here now we can just do constants.bird width and constants.bird height. And our bird not gonna need any of these, but it will need a pose 1. Alright, let's see how does it look. Okay, we have a bird and it flies off the screen. Yay. Alright, next things. We want the bird to be animated, so let's do this in our physics. Physics. So I already have a tick 0 defined here. So basically what we want to do is mutate the pose attribute of our bird object on every let's say five ticks. Yeah. So first of all, increment our tick on every tick. If tick divided by 5 equals 0, pose equal pose plus 1, let pose equal 1. If pose is greater than 3, pose equals 1. Simple. And assign it to the bird. Entities.bird.pose equal pose. Symbols. Now if we reload, our bird is nicely flapping away. Great. So okay, that kind of, well, not yet, but kind of ticks of this. Let's start moving the floor. So what we need to do here is object.keys entities dot for each key. So what we do here is for every key in the entities, and if key.index of floor equals 0, like exact 0, then if entities, well, matter.body.translate. So I want to move the floor by 2 pixels. So entities key.body, and on the x-axis move by -2, on the y-axis don't move it at all. So if I reload this, like the floor is moving, but you're gonna see something in a second. Yeah, eventually it ends. So what we need to do is when one of the floors are moving off the screen, quickly move it back, which is super simple. If entities key dot body dot position dot x is less than equal -1 times constants dot max width times 2, divided by 2. So if the center of the floor is minus half screen worth of the screen, then matter.body.set position entities key.body and we want to move it to on the x-axis to constants.max width plus max width /2, and on the y-axis entities key body position y, right? And only do this if it's the case here. Okay. All right, so we have a nice continuous floor. Okay, so let's fix our gravity and flappiness. That's one of our things on the list. Fix the bird flappiness. Basically, what we did before is apply force, which is it's problematic because apply force applies the same force no matter what, even if force has been applied before. So if the user taps rapidly, then you keep adding force and your bird flies off the screen. So let's fix that. First of all, this touches. If you tap the screen with like 4 fingers, it will send in 4 touches, and we really only want to apply it once. So head touches equals false. If not head touches, so in every loop we're gonna reset it to false, and we basically only want to apply 1 touch per tick, right? And what we want to do here is, instead of apply force, we're gonna do set velocity on the bird, and we're gonna set the velocity on the x-axis to be bird.velocity.x, so don't change that at all. I don't like curly braces like this. And on the y-axis, let's apply a -10. Velocity is different than force, right? Okay, but we still don't have. First of all, we had to do head touches equals true. We don't have gravity yet, so if world let world equals entities physics.world, if world.gravity.y equals 0.0, then world.gravity.y equals 1.2. So on the first touch, we're gonna set the gravity, set the head touches, and set the velocity. And let's see what do we have. And we have a nice flapping bird. And the collision what we brought last time still works. All right, that's actually, I didn't even save that. Hold on. Oh no, okay, it's fine. Okay, so that takes care of this. One thing I wanted to add is, you know, like the bird is looking in one direction constantly. I want it kind of to rotate. So let's modify our bird to rotate based on its velocity. That's relatively simple to do. We need animated for it, and I want a constructor props super props, and this dot animated value equals new animated value. This dot props dot body dot velocity y. So Matter.js has a velocity object on every body, like every comma body, and this velocity will be the speed on the y-axis. So when I click it, it will be a negative value, and as it starts falling, it will be increasingly positive, right? So first on render, what we want to do is this.animated. So I want to update the value of this. Set value and set it to the current one, right? And I want a rotation, which will be this.animated value.interpolate. Input range will be. So when the bird goes up, it goes to negative, like let's say it goes to -10. Then it goes back to originally it's 0, and then it's 10, and maybe it hits 20 as it's accelerating down. Output range. Now we have to define rotation degrees here. So when it goes up, it rotates to like -20 degree. When it's idle, it's 0 degree. When it starts falling, let's say it's +50 degree. And when it's like super quickly aiming towards the ground, let's say 45 degree, and extrapolate clamp to make sure that if you go out of that range, nothing bad happens. And change the image to be an animated image, and do a transform which accepts list, and rotation. Cool. I think this might actually work. Yeah, so you can see how the bird is rotating. Amazing. Okay, pipes. Pipes are fun. If you go back to the end result, I want this kind of pipe, and as you notice, the top of these pipes are different. So I'm gonna have two components to render this. I'm gonna rename my wall to be a pipe. Rename. It's a pipe component, and I'm gonna use the same width and height as here. Amazing. Okay, so we don't need background color for sure. I want an overflow hidden, and I want a flex direction column. Basically what we do here is pretty much the same what we did for the floor. We're gonna render image tiles. So our image here, we have a pipe core, which is kind of like this, so we have to duplicate it multiple times. Okay, how do we do this? So const pipe ratio. So the original width of the pipe image is 160, so the ratio will be this. Const pipe height equals the original height is 33 times pipe ratio, and const pipe iterations equals math.ceil height divided by pipe height. Cool. I want to import image, and I also want to import this one, and just do the same thing as we did before with the floor. Pipe iteration, pipe height, actually this is width, and this is pipe core. Alright, so that takes care of our pipe. We want a new one, which is pipe top.js. This will be a super simple one, very similar to bird actually, except We definitely don't need animated image. We just want width and height. Image will be images.pipe top. We don't need any of this nonsense, neither this. Pipe top. And I think that's about it. Yeah. Okay, cool. Now, originally we set up pipes in app.js, but using generate pipes and random between, we really don't want to do that. Keep things simple. We want to do it in physics, so I'm gonna move these. I want to know how many pipes are on the screen or in the word, so I'm gonna add that, and I'm gonna create a new function, like a helper function, which is export. I might reuse it somewhere else, so I'm exporting it. I really shouldn't. Which will be add pipes at location, which will receive an X, a word, and a list of entities. Okay. So basically, for every pipe set, we need to render four items, 2 pipe cores and 2 pipe tops. So let's get to it. Let pipe 1 height, pipe 2 height equals generate pipes. Cool. So this gives us two random numbers actually. So let pipe top width equals constants dot pipe width. So I want the top of the pipe slightly bigger than the core, so I'm going to do like 20. Let pipe top height. So pipe top width divided by the original image size is 205 and the original image height is 95. Cool. And pipe 1 height is pipe 1 height minus pipe top height. I have to deduct it from the height. Okay. Let me import a couple of things. I need an import pipe from /pipe and import pipe top from /pipe top. Cool. And let's create the pipe. So pipe, let pipe 1 top will be matter dot bodies dot rectangle. Okay, so this will be the top of the top of the top pipe essentially. So the center of it will be X, that's passed in. The Y will be pipe 1 height plus pipe top height divided by 2. The width pipe top width and pipe top height. Okay, and very important that it's is static true. Okay, let pipe 1 equals, so this is the actual pipe core. Rectangle will be X again, pipe 1 height divided by 2. It will be constants dot pipe width, and it will be pipe 1 height, and again it's a static one. Cool. So we have let me make a copy of this. So this is the bottom set. Like again, pipe 2, we need to deduct this, and this will be a bit more complicated. The x is still the same, but it will be constants.max height minus the floor will be 50 pixels, so I'm going to deduct 50, deduct the pipe 2 height, and deduct pipe top height minus 2, top width, top height, static. Cool. Pipe 2 x, this one is the same, not minus pipe 2 height divided by 2, same width, and the height is this one. Okay, I think this is it. I'm pretty sure we made mistake or two. Now add matter.word word.add word. So let's add it to the matter word. We want pipe 1, pipe 1, pipe 1 top, pipe 2, pipe 2 top, and add it to the entities pipe plus pipes plus 1 equals body pipe 1 renderer pipe. I want the same for pipe 2, so add 2 here and 2 here. Then I want pipe 1, I'm gonna call it top, pipe 1 top, top, and a pipe 2 top. Okay, and the last thing to do is increment the number of pipes. Pipe plus equal 2. Okay, let's try if it works. So basically, when we do our first touch, let's add things to the screen. So add pipes at location. We're gonna add it to constant dot max with minus 100 word entities. All right, moment of truth. Let's see. And of course, the stupidest mistake. And let's rerun it. Cool. So yeah, it actually added things. Of course, it's not moving, but it's a good start. Okay, so yeah, there, but it's pretty close to us. So let's do it like, let's add it to let's add it pretty far from us at the beginning. So times 2 plus minus constants dot pipe with dash 2. So this will add 2 screens from us at the end of the first screen, essentially, and add another set like free screen from us. Okay, so and let's start moving them. So here we can do if key dot index of pipe equals 0, and put this as if. Then just do this actually. No, not this one. This one. Right? Just translate it by yes. Okay. Okay, I think I need to adjust certain things like the gap size. It's way too small for us. Anyway, it kind of works. There is another set. I'm gonna make it slightly bigger, just so it's easier to test. Except I suck at this game. Seriously. Okay. Anyhow, it kind of works. I'm gonna make it super big, so we can actually test things like scoring and stuff. Okay. Now even I can deal with this. Yeah, except I don't. Okay. So as you can see now, these pipes are going off the screen and never coming back, so let's fix that. Okay, so now we have, keep in mind we have 4 things that starts with pipe. So what we need to do is essentially let's nominate one pipe from the pipe set that gonna be your trigger for certain events. So I'm gonna nominate the bottom pipe core. How do I reference this? So if key dot index of top, so it doesn't have the top in the name, and parse int key dot replace pipe to 0. So I'm gonna remove the pipe from the name and parse it to be an integer. Modulo 2 equals 0. So this is a bottom pipe. Then we can do stuff, right? So if entities key dot body dot position dot x less than equals -1 times constants dot pipe width 2. So it just went out of the screen. Pipe width 2 in the negative direction. What we want to do? We want to actually delete the existing pipes. So delete entities pipe plus. Actually, I'm gonna create a pipe index. So I'm gonna delete the previous one because we know this is a bottom one. There must be a previous one. So delete the top. Delete just the normal one. Then delete this top. I don't need brackets. And delete just the normal one. Okay. And also I want to add the new one 2 screens from now. Yeah. Now we're gonna run into a problem. I'm gonna show you why. If I manage to go through 2 sets of pipes, actually it's enough to go through 1 set of pipe. And we didn't go through. Okay, ignore me. Yeah, I know. Okay, that is fine. We have kind of a cool game. We have to take care of scoring. In order to do some scores, let's add things to our app.js. So I'm gonna create a new text node that will hold. First of all, let's add the score in our state. And I'm gonna create text style. Do we have text? Yes, we do. Text style styles dot score, and this state dot score and text. Okay. All right. So I'm gonna do a score, which will have a position absolute. What else? We'll have a color white. It will have a font size of huge, 72. It will have a top 50. It will have a left, which will be constants.max width divided by 2 minus, let's say, 30. Okay, and we want the text shadow color, which will be 444. So unfortunately, React Native doesn't have like a stroke and that you can apply on text, but you can emulate it more or less with text shadow, although it might not work on Android. Actually, it definitely doesn't work on Android as of today, but they are working on it. So we do offset to 2 and text shadow radius of 2. Okay, so we might have a massive. Okay. So there is a number, and we want a font family, which will be 04B_19. Very nice name for a font. Amazing. That kind of, it's almost center, so I'm gonna do 24 here. It's kind of there, maybe 20. It's difficult with fonts, to be honest, because you can't really calculate this properly. All right, so we have a score. So let's define a. Remember how we listen to events like game over. So do an as here. Actually, as if e.type equal score. This set state score. This dot state dot score +1. Okay, cool. One thing is in reset we want a score to be 0, and also remember how we have these pipes. So I want to export const reset pipes, which is an empty function, pipes equals 0, and I want to import that set pipes, and I want to call it on reset actually. Okay, so when we die we reset this internal counter. Okay, cool. Now how do we figure if basically what we need to detect is our bird crossing the threshold. Yeah, so how do we do this? Again, we need to nominate a pipe that we do detection on, and that will be actually the same pipe. So what we can do, if entities key dot body dot position dot x is less than equal than bird dot position dot x, so our bird the pipe is behind the bird, then we need to include a dispatch, and we need to dispatch score, type score. Okay, so if I run it, there will be something funky, and you will see what I'm talking about. But two, yeah. Oh, score as a string. That wasn't the funky thing I was referring to. See, the number gonna keep increasing. So let's modify our pipe to have a physics. So when we define our pipe 1, we gonna do a scored is false. I did too much Python lately, and yeah, I'm doing capital F for false. Okay, so if that pipe, where is it? And entities key dot scored okay, so this is gonna work, but we will run into another issue. Just one sec. So when the pipe goes out of the screen, there will be an issue. Actually, there wasn't, but there could be. Remember, we are in an iteration of entity keys. Now, we are deleting entity keys, but we are deleting parts of the entity's object, but the keys won't change. So there could be a case when we delete the underlying value, but the iteration continues and it hits one of the non-existent values. So what you need to do here is add a simple and entities that has own property key, just to make sure the key still exists in the entity. Otherwise, don't go in there. Right? Okay, so I think we are getting there. So 1, 2. Oh, I'm on a roll. Yeah, okay, nice. One tiny thing for then. So we have the game over text. Game over text. Let's change the font on this as well. And let's do game over subtext, which will have a, I don't know, 24. Game over subtext. Try again. Looking pretty neat. All right, I think we are done. I mean, it's obviously not ready for the App Store yet. You have to keep like high scores and maybe implement some advertisement, maybe add in-app purchases to buy a Bluebird or whatever. But it's pretty close and it's actually pretty fun to play. I tried it on my phone. It runs relatively smoothly. I do not recommend publishing it to the App Store because there are thousands of Flappy Bird clones in the App Store. But maybe implement your own twist to it. Like you can come up with variations that no one did it before. You can make the bird shoot bullets or whatever. But yeah, this is it. Thank you for watching. If you like the content, please subscribe, hit the like button, leave a comment. That way I know you are engaged with the content and it encourages me to create more, subscribe. I wrote a Medium article. It will be linked down below. And yeah, that's it for today. Have a nice one. See ya.